Hi, I'm Mr. Huber, and in this video we're going to look at problem 3f. Rewrite each function in factored form and find its zeros, y-intercept and vertex. Sketch the graph qualitatively. Well, f of x is equal to x squared plus 9x minus 90. So first we have to look at the 90. 90 can be achieved by multiplication 1 times 90, 2 times 45, 3 times 30, 4 is not possible, so 5 times 18, 6 times 15, and 9 times 10. And from now on it would change 10 times 9 and everything, so it's the same thing again. Now this is negative, so that means one of the two has to be negative. And well, when you look at it, it will be this one. Why is that? Because when you add them up, you have to get 9. So if you do this, minus 6 times 15, well, that's minus 90, and minus 6 plus 15 is 9. So that works. So we can write x minus 6 and x plus 15. So let's set this equal to 0. Well, then x minus 6 is equal to 0, so x is 6. X plus 15 is equal to 0, so x is minus 15. So these are the two zeros. So if you wanted to draw the graph, you would probably get something like this. Well, minus 90, that's your y-intercept, so you get 0 minus 90. So let's say that's down here somewhere, minus 90. And then you have minus 15, one of the zeros, and the other one is at 6. So you would probably get something like this. Here we go. And we know that our vertex is right in between the zeros, because the function is symmetric with respect to the vertical line through the vertex. So we can work out xv, the x value of the vertex. Well, it's minus 15 plus 6 divided by 2. That's minus 9 halves. Now, in order to work out the y value, you just plug it in here. So f of minus 9 halves would be minus 9 halves, and then minus 6, that's minus 12 halves, and then minus 9 halves plus 15, which is 30 halves. So you're going to get minus 21 halves times 21 halves. So that's minus 441 quarters, which is minus 110.25. And that does make a lot of sense because it's below the minus 90. So here the vertex is at minus 9 halves, minus 441 quarters. That's the vertex. Or if you want, you could write it in decimal numbers, minus 4.5 and minus 110.25. So now you have 4 pieces of information. You know the zeros, you know the y-intercept and the vertex, and you get a pretty good idea of your graph. Now look, this one you could have done by using this method here, well, with the completing the square method. Well, the thing is, this one here worked quite well, but it doesn't have to be like this. It could be more complicated. For example, if you had a 10 here, x squared plus 10x minus 90, you would not find a possibility to get your 10 here. So that would not work like this. You wouldn't find integer zeros, but you could still do this method. You could still use this method, x squared plus 9x minus 90. You could complete the square. So x squared plus 9x plus 9 halves squared minus 9 halves squared minus 90. So this will be your perfect square. So it's x plus 9 halves squared minus 81 quarters minus 360 quarters. 90 is minus 360 quarters. So here we go. X plus 9 halves squared minus 441 quarters. So the vertex now would be minus 9 halves and minus 441 quarters. We got that too here. Then for the zeros, you would set this equal to 0. Quarters is equal to 0. Well, that's in fact f of x is equal to 0. So you're asking for which x is the f of x value, the y value 0. So that's quite easy to work out here. 441 quarters. Then you have to take the square root. So you get x plus 9 halves is plus minus the square root of 441 quarters. X plus 9 halves is plus minus 21 halves. Okay, 441 is the perfect square made out of 21. 21 squared is 441, and obviously 2 is the square root of 4. Now x is minus 9 halves plus minus 21 halves, which then results with a plus in 12 halves, that's 6, and the other one in minus 30 halves, which is minus 15. So look, these are the zeros here. But you can see this is quite a bit more laborious, okay? Quite a bit more difficult. So if you can do it like this, you're quite fast. And oftentimes we don't even work out the vertex. We just draw it like this. We know the minus 90 and we don't do the vertex because when you remember, when you look back in a video, I drew this graph before I had the vertex. It's not even that interesting. I get a good idea of my graph even without working out the vertex. But here, this is the version or the method that will always work in every case. Okay, hope it wasn't too difficult. See you on the next one.